Again, so for these bottom ones, what I would choose to do is subtract 2 from both sides. We would get 13x is equal to 11x minus 3. Then I would subtract 11x from both sides. And I would get 2x is equal to negative 3 divided by 2 divided by 2. And we would end up with x is equal to negative 3 over 2. So the x value should be negative 3 over 2. That's by solving algebraically. We'll talk about graphing in a moment, but I'll do the algebraic piece first. So we're going to remember that our x value is negative 3 over 2. And then what we're going to do is try to determine what our y value would be. And so we can separate this equation into two separate equations. Y equals 13x plus 2, and y equals 11x minus 1. And if we were to substitute negative 3 over 2 in there for x, what we would end up with is negative 39 over 2 plus 2 would be negative, that's weird, let me get the calculator and do a little bit of work there because I don't want to mess with fractions. If I were to go ahead and give that to a calculator, I would get y equals negative 35 over 2. And the same thing would happen with the equation on the right. If I gave that to a calculator, I would get y equals negative 35 over 2. And so again, you should be doing all your work on a separate sheet of paper. You're never going to have enough room to do it on here. And so negative 35 over 2 would be our y value. I have no idea who wrote this book, but whoever it is needs to give their head a shake. These problems are very not appropriate. And then the other piece is that there's no way that we're going to be able to graph this on that tiny graph, because you would have a slope of 13 and a slope of 11. And how are you supposed to fit that on that little itty bitty graph? You can't. So, moving on to the next one, we do have the same y-intercept and a different slope. So we know that this one is going to have an intersection on the y-axis. And so if we were to graph this one, again, you can't, because 9 is too big to fit on that graph. It's ridiculous. And so I would go to algebraically solve this. We would add 3 to both sides. And we would have negative 9x is equal to negative 4x. This looks weird, and it is. They're choosing to put lots of strange off-the-wall problems in here instead of more standard stuff, which is really annoying. But basically what we need to understand is that the only way for negative 9x and negative 4x to be equal is if x is equal to 0. Because negative 9 times 0 is 0, and negative 4 times 0 is 0. And so in this case, our x value would have to be 0. If we test that and put it in, and we separate this into two separate equations, y equals negative 9x minus 3, and y equals negative 4 negative 4x minus 3. If we put 0 in there for those, in both instances we end up with y is equal to negative 3. And so we could say that the ordered pair, or the solution here, I'm going to maybe pause before I erase right now, the y value would be negative 3. Again, these problems are just on the far side of ridiculous, and so moving on with what we've got here. I have no idea why this got green for some reason. Here at the bottom. Let's see if it's still green. Maybe I'm not using the right pen. There we go. That's why I was using a colored pencil. Okay, so down here at the bottom, this would fit on the graph. I'll actually bounce over and do it. Negative 1/3 x plus 2. So if we tried like negative 1/3 x plus 2, we would end up with that. Negative 1/3 would look like this. Oops. So there's our first one. Y equals negative 1/3 x plus 2. And then our other one, 2/3 x minus 1. We would have negative 1 up 2 to the right 3. So they have an intersection there. So the solution for this one is going to be right there at the point 3, 1. So that's how you would do that graph. I'll go back there so you can take a moment there. If you need to pause, go ahead and do so. And then solving this algebraically, we would have a process would be subtract 2, negative 1/3 x is equal to 2/3 x minus 3. And then at this point we would add 2/3 to both sides, 2/3 x. You could choose to multiply everything by 3 to make the denominators go away, as you recall. You would end up with 1/3 x is equal to negative 3. And I'm sorry, that should be subtract 2/3, my bad. So we should be subtracting 2/3 and adding it. And we would get negative 1/3 plus negative 2/3 is negative 1x is equal to negative 3. If we divide by negative 1, we get x is equal to positive 3. And so x is equal to positive 3. I'm going to pause so you can get that down if you need to before I erase. And we would have, so an x value of 3. We would have negative 1/3 times 3. Actually, let me back up and do more proper with my approach here. We can split this into two equations, y equals negative 1/3 x plus 2, and y equals 2/3 x minus 1. If we put 3 in there for both of them, we should get 1, so that it would match what we found graphically there. So y equals negative 1/3 times 3 plus 2. Y equals, that's going to be negative 1 plus 2. That's going to be equal to 1. Y equals 2/3 times 3 minus 1. That's going to be 6 over 3, which is 2, minus 1, which is 1. So in both instances, we end up with y equals 1. That matches the ordered pair that we found when we graphed it, and so we know that that's the correct answer for that one. These are tough.